I probably should not be making a video today. I've been trying to make this video for like 40 minutes because of my printer. And when it comes to technical things like this, I am really impatient. If that isn't too obvious. And it turns out it wasn't even my printer, it was my phone. Then I thought, well, this video might be more entertaining if I just didn't censor myself and just got on here with just the way I feel and just be as authentic as I can possibly be. It's not zany, not feeling particularly zany today. So that's kind of where I am. Let me summarize again what's happening with this Graham Oppy and him addressing the applicability of numbers. So what's going on with the applicability of numbers? If you remember from last time I discussed this, this is part 2 of the first thing about Graham Oppy I'll be doing, and then there'll be a third part dealing with his response to applicability of numbers, is that there's this unreasonable effectiveness when it comes to numbers, that there's an aesthetic impulse, okay, what we've classically called a muse, right? That's what artists call it, a muse. And it's an inspiration that the mathematician gets, okay? And then they set out to do the mathematics, and it works. And it works with an extreme level of effectiveness. Now, Oppy, if you remember last time, said, well, I don't know that it's an aesthetic impulse so much as it is your motive is to solve problems. I didn't say this at the time, but I think it's a little bit of an oversimplification. I think it's certainly you would solve problems, and John Polkinghorne said that. However, you also are going to need to do a whole lot more than just want to solve a problem. There has to be something making the mathematician want to do this, but it turns out it's more than just calculating numbers, that these extreme levels of mathematics, like this, like E equals mc squared, these general relativity and special relativity and all that, it turns out there's this bizarre, what I'm calling an uncanny accuracy. Oh, see, I did this uncanny, that'll be the pick that YouTube picks for me. I was going to try to learn how to put my own thumbnails up, and then I realized that half of them look like a Satan worshiper. So I thought, well, maybe that also may be entertaining to keep up. So there's this strange effectiveness. Now, the zany professor said he didn't want to be around me today because of the mood I'm in. So Oppy, I think, really shows how smart of a guy he is here. In his second, he offers 3 responses in this debate he's having with William Lane Craig. And he is just, I could have never have even conceived of this argument. I was just shocked. I was like, man, this guy's good. He's really, this is what I mean. If you watch the Unbelievable Big Conversations, watch the one with Peter Singer. This guy is sort of a renowned ethicist and philosopher. And when he's challenged, his arguments, or even Grayling, look at Grayling too, their arguments are just so weak. I was going to do the Peter Singer one this week, and I'm like, I need a break from it. I want to deal with a heavy hitter. I want to deal with a heavyweight. And Oppy, man, he brought the goods, man. This is a really interesting argument. So he says this. I'm going to go over my notes and try to make as many comments about them as we go. I'm not going to put a cap on the time here. So Oppy says this. He says, we don't actually know the laws of nature. Now, this is interesting. And this kind of thing is why Oppy's teaching me, listen to your opponents. Listen to them. Hear them out. And that's one thing I'm learning from Oppy, is that it's good to hear what your opponents are saying and really take it in. And he's saying, I don't know that we know what the laws of nature are. Really good point, but this gave me insight into something here, okay? So if we don't know the laws of nature, how do we know that our mathematics are accurately reflecting the laws of nature if we don't know them to begin with? Now, you might go, well, it's because there's this unreasonable effectiveness. Yeah, but listen to what he's saying here, and he gives a really good example. He's like, but why, if we don't know the laws of nature, would we make an assumption that mathematics leads to what the laws of nature are? And so he says that he gives a really good example. He goes, take a look at how we discovered Uranus. He's like, we did all of these mathematical projections. We used these Newtonian laws. They told Galileo, point your telescope, and they found Neptune. And he says, then they try to find the perihedrium of Mercury, and the Newtonian mathematical equations were wrong. And he said, so if the math is wrong, but ends up finding correct answers, how can we be confident that that they're actually reflecting the laws of physics, the laws of nature, when we don't even know the laws of nature? It's a really good argument, man. I was like, wow, that's pretty good. Like, I would never, I've just for a long time considered naturalism to be such a bankrupt idea. And I still believe that, to be totally honest with you. I just think of all of the alternatives and worldviews. Why would you settle on that? It just seems like its explanatory power is so weak. And I still believe that. But I think if anyone is going to convince you of it, it's Graham Oppy. Anyway, I'm sorry. I'm excited to really interact with a great thinker, because that hasn't been happening even once with any of the atheists. I might respect some of them. I might appreciate the effort some of them put in, but none of them have been great thinkers. He wasn't technically an atheist. Sorry, that's for another time. All right, so he says that some formulas can be wrong, but still yield correct results, right? He says this would seem to indicate that they couldn't possibly reflect the actual laws of nature. Now, here's what I would say. This is the insight that he kind of gave me, and I'll go over what Craig, said here in a moment if it comes up as I'm talking about it. I would say Oppy's problem here is that he doesn't like, at least tacitly, he doesn't say this, but I think he doesn't like that this is an inductive argument. But that's all we got. Okay, now what do I mean by that? Well, so deductive arguments are just basically you reason from the general to the specific. And that's the best way, I think, to reason through things if possible, but it's not always possible. Abductive is a little bit more slippery. It's just sort of like, it's kind of like the way detectives, I've always just seen illustrations of it. I don't really quite understand formulations, maybe because there's so many of them. But basically, one I heard was really good. If you walk into a room and all your papers are thrown about and see an open window, you think the wind did it, but it is possible there's something else that could have caused it. Like your roommate went in there and did it or something like that and made it look that way. Whatever, that would be more abductive reasoning. But inductive reasoning is reasoning from the specific to the general. And while it's not ideal compared to deductive, sometimes it's the best you have. Also, considering the effectiveness of mathematics, we're kind of left with trying to do the best with what we have. And so inductive reasoning seems to be the best. Given that there is not an array of alternatives postulated by Oppy, then there seems to be no good reason to reject Wigner's assertion. No reason to reject Wigner's assertion on the grounds that it is a general conclusion. So, yeah, I think what's happening here is, so Oppy is his point here would be fine if it hadn't been that there is an effectiveness to this mathematics. Since I don't know the laws of physics, and neither does anyone else, ultimately, We only have math to show that to us. So he kind of has to say, okay, since he doesn't like the inductive conclusions, maybe he can offer an alternative. Now, it may sound like I'm shifting the burden of proof, but the reality is this is an answer, and I'm not seeing an alternative here from him. So now what Craig says is he just doesn't see the problem with it. And look, in a short debate like this, where you don't have time to sit back and analyze it, I could see why Craig would say that. And Craig's not wrong. It's just not as specific, I think, as maybe I'm wrong, but it's not as specific as I think I'm being, which is that there's some inductive concerns here. He seems to feel that this is not a special reality if it's so flexible. But again, it can be flexible because it's a general conclusion anyway. So the burden of proof for alternative lies, in my opinion, with Oppy. Now, he might respond that he is not obliged to find the mathematical fit, is the term he used, and that I'm shifting the burden of proof. And I might respond this way. He has offered no defeaters and no alternatives to Wigner's claims. So why would one change their perspective? There's no reason to say that Wigner's wrong because there's an absence of defeaters and alternative perspectives here, alternative postulates. So additionally, and this is where it gets kind of technical here, and I might be wrong about some of this. So I think I'm pretty accurate on some of that, I think. But moving on here, I could be the zany professor, rather, getting the two confused. Me and the zany, how could I get that confused? Stay tuned, there could be more. Additionally, in math, unlike language, take everything else I'm saying here with a grain of salt, okay? I'm thinking through things that I kind of ran out of time, and I wish I could have thank more on it. I wish I could have thought more on it and kind of did a little more research on this. So additionally, math, unlike language, is univocal in nature and therefore highly precise, as demonstrated by our ability to use it to explore even before we perform observation. So, for example, we've kind of confirmed the existence of black holes, but we did it way before that because the math is always on. It's always spot on. Does that mean there's never been mistakes made? Of course not. And Oppy even said this. He's like, there's been no empirical data collected for how many mistakes are made. Yeah, so, well, and I'll explain that in a minute. So this makes Craig's argument that partially correct theorems are still a valid expression of the applicability of mathematics, and it makes it even more profound, in my opinion. So Craig basically responded to him. He's like, look, when we do these theorems, he said, particularly in the case of Newtonian theorems, where they were right about some things but wrong about others, they just had a partial inclination, and it just shows, you can make the case that it maybe shows it to be even more accurate. Pretty interesting. So a side product of Oppy's argument is that it kind of functions like the multiverse theory. Now, what do I mean by that? And I don't think he directly meant it this way, but it kind of operates this way. So when you look at the initial conditions of the universe, it appears that there's some form of fine-tuning, that things were just perfect for us to have. There could have been many other alternatives. We may not have even been able to have a physical universe. Yet, everything happened in those initial conditions for what is called fine-tuning. Now, you would think if this was a problem, naturalists and so forth would come out and just rail on it. They don't. They don't. They see it. So they argue for the multiverse theory. And the multiverse theory is if you have an infinite amount of universes, and I did this a little earlier in the Unbelievable reviews, but if you have an infinite amount of universes, then you would expect eventually for one of those universes to have the conditions we have. And Oppy's argument kind of like that a little bit. It's saying, look, we have so many cracks at getting it right. Who knows how many we got wrong before we ever got one right? Yeah, eventually you're going to get one right. I think that's a problem. Okay, now my response to this, it's the actual formulation of the math that's astonishing, not the amount of formulations. So when it's done right, there's this like almost like a kinetic chain, right? It's or epistemological chain, I should say, I guess, where it's you unlock this. We even, as we explore the universe, we even explore new forms of math, which unlocks more things that explore new parts of the universe. So is it the amount of math, or is it the amount, or is it the robust formulations that we should be considering here? Okay, I hope that makes sense. All right, so I'm going to reread this. So my response, it's the actual formulation that's astonishing here, not the amount of formulations. That any mathematicians could or would be accurate given this state of affairs is what makes this so remarkable, okay? So again, very deep, robust calculations that end up being accurate, unlocking more math, that more forms of math and more theorems that unlock more physical understanding of the universe. That is uncanny. That's unreasonable. And saying, well, no, we took so many cracks at it, so what? And if Polkinghorne's right, history plays out that there should be a beauty to the sequence as well, in that math that didn't possess this aesthetic beauty was typically wrong. That's kind of insane to think about. So who cares how much of it was wrong? It doesn't matter. What matters is what was right. You see what I'm saying? So I think that's sort of a side product of his views. So mathematical artifacts possess no causal properties, yet the link is undeniable, leaving, zany note number 2, major questions about math's place in our metaphysical understanding of the universe. So there's no causality between these formulations in the universe, but why should we expect to see this relationship? So even one is so even just take one of these really complex theorems and you'd be astonished. So it seems to me, so then number 2, so we can explore the physical universe with mathematics with extraordinary precision. So even if we are wrong or merely estimating, the problem still remains for the naturalist. And I think that's true. Now, why would we expect all mathematics to be perfect for it to qualify for this unexpected explanatory power and precision? I don't believe that we would. So given that we are so prone to mistakes, one could make the case that it's amazing any mathematics is that precise ever. So asking for pure precision to qualify as unreasonable effectiveness is really to introduce a relative notion in a clearly objective observation. So it's almost like he's infusing this relative idea. Hey, look at all this math that's wrong. You can't do the research on it because who would keep track of that? Good point. Yeah, it's almost like he's saying we're just pecking at it till we get a right answer, but that's not what we're seeing. We're not seeing pecking at it till we get a right answer. We're seeing incredibly detailed, incredibly precise answers. I'm not to be too repetitive here, but that unlock even more understanding in mathematics that we'll probably make more mistakes on, right? So what I mean that he's offering kind of relativism is to say, well, it seems like kind of relative, right? I mean, we pick the ones that are right and the ones that are wrong, and we're saying it's unreasonable. I don't believe so. Again, it's not like language where it's analogical. It's mathematics, which is equivocal, okay? So, point here again, just to make it very, very clear, is that it's not relative. Even though I don't think he's directly arguing for relativism, the net effect of what he's saying is a relativism of sorts. And that is unacceptable. That's not the way it is. Additionally, we can only calculate a finite amount of math, right? In the history of the universe, as humans have been around, we haven't had a lot of time to calculate a whole lot of math, right? So this is what I mean by the relativism. So let's take a look at it from that perspective. Since these complex formulations in the history of the universe haven't been around that long, couldn't you make the case it's kind of amazing? And I call this an argument from propinquity, which is to say the closeness of the math. There's been a close availability of these mathematics for a very short period of time. How can he respond to that? Well, says you. Right? See the relativism coming up here? It's really interesting. So additionally, we can only calculate a finite amount of math. Therefore, the precision is not accidental or by chance. Oppy may have inadvertently enhanced the argument for the applicability of mathematics as it has presented itself with open accessibility in a finite period of time. Would this accessibility not make it, zany number 4, not make it more available for man in an uncanny way? So math may also have an uncanny propinquity and is yet distant in its distinction from the human mind. So we wouldn't say math is something that's only in the human mind. Graham Oppy's not even saying that. And yet it's closely available in a very short period of time. That's strange. Very strange. And that's what I mean, that he's kind of almost enhanced the argument for theists here. So math may also have an uncanny propinquity and is yet distant in its distinction from the human mind. Given naturalistic assumptions about the mind-body monism that they embrace and the billions of years of the life of the universe and evolution, why and how could math make itself so close, so available? All right, so that's my conclusion to the second part of my look at this first section of Oppy. Like I said, I'm going to do kind of 3 debates Oppy does and just try to understand the man a little bit. I don't know how adequate those responses are. Like I said, just consider them something to think about. Don't go home with them and say, we've got all the answers. I'm just a schmuck sitting here in my house trying to get the zany professor to send me some facts, some faxes. You know what I mean? So, but I would say this is good food for thought to say, but I want to conclude with this. Mad respect to Graham Oppy. Incredible thinker. Incredible.